Okay, and last, we're going to look at the negative exponents. Okay, so x to the negative n. If you have a negative exponent in your numerator, you just put in the denominator and make it positive. And if you have a negative exponent in your denominator, you just put it into your numerator and make it positive. Okay, so for example, if you have 3 to the power of negative 3. And clean that up a little. Okay, you just make that 1 over 3, and you make your exponent positive. So that would be 1 over 27. Okay. Same thing if you have a negative exponent in your denominator. So you have 1 over 2 to the power of negative 3. Then you just put that in your numerator, which becomes 2 to the third power over 1, which is just 2 to the third power, which is equal to 8. Here we go. Okay. So the reason we reviewed all of those was to set us up for our, as you can say, your root value notation. Okay, and that's the nth root of a. It was equal to a to the 1 over nth power. Oh, that didn't erase. So it's equal to a to the power of 1 over n. Okay, so for example, if you have the square root of 4, remember when there's nothing there, we just assume it's a 2. So that would be 4 to the 1/2 power. Or if you had the cube root of 27, that's just 27 to the 1/3 power. Okay. Or if you have the fifth root, say the fifth root of 625. And that would just be 625 to the 1/5 power. So whatever your index is, it just goes in the denominator. Okay, so we're going to use this as long as with all of those exponent rules to solve. Well, not really solve, more of simplify. Say negative 27 x to the 3rd power, and we'll raise that to the 1/3 power. Okay, so we know I have negative 27 x to the 3rd to the 1/3 power. We're going to look back at the rule that's a times b to the nth power is a to the n times b to the n, which means we're going to get that exponent and just distribute it to both of those factors. Okay, so that's going to equal negative 27. Clean that 7 up a little. Okay, so negative 27 to the 1/3 power times x to the 3rd. to the 1/3 power. Okay, so all we did was distribute our exponent. Okay, then we're just going to use the rule that states that a to the power of m raised to the power of n is equal to a to the m times n. Okay, so that helps us along here because that gives us x to the 3rd power raised to the 1/3 power is just x to the 3 times 1/3, which is just x to the 1st power, or just x. Okay, so whenever you have an index, or I guess you could say your index is your denominator here, and your exponent, and they're both the same, they cancel each other out. So that just lets us know that the cube root of x to the 3rd power, actually that should be underneath it, cube root of x to the 3rd, your exponent and your index will always cancel out, so it'll be x. Okay, so this gives us the, if you want to rewrite it, you can, if it just makes you understand it a little bit better, the cube root of -27 times x, since we already figured that out. And we know that -3 times -3 times -3 is -27. So that just becomes -3 times x. Okay, so any questions on that one?
Okay, so for the -27
Mhm.
times the 1/3,
Mhm.
when you brought it down, did it just change it to the square root?
Yep, all I did was rewrite it.
Okay.
Yep, so just have the cube root of -27 is just equal to -27 to the 1/3. And you don't have to do that, just sometimes they rewrite it into root form. Kind of looks a little more familiar. Okay. Any other questions on that one? All right. Move that up a little. Okay, so what if we wanted to simplify? (256) times a to the 8th power, and we raise that to the 1/8 power. Okay, so we use the exact same rules for that one. We use this rule here because we're just going to distribute our exponent. Okay, so 256 a to the 8th to the 1/8 power. It's just going to equal 256, which we don't really need the parentheses if it's positive. So we can go 256 to the 1/8 power times a to the 8th to the 1/8 power. And again, if you wanted to rewrite the 256 to the 1/8 power, you could. So you can take that as the 8th root of 256. Remember that 8 times 1/8 is just 1. So whenever your denominator and your exponent match, they cancel each other out. So that's just times a. Okay, and we know that 2 times 2 times 2 times 2 times 2 times 2 times 2, I think is one more. 1, 2, 3, 4, 5, 6, 7, 8. Yep, equals 256. You may not know it off the top of your head, but you can easily figure it out. Okay, so we know that is just 2 times a. And my circle went right through there. Let me clean that up some. There we go. All right, so does that make sense? Okay, any questions on this one? All right, I'll leave that up for a few more seconds. All right. So we can see here all of our fraction exponents always had 1 over whatever our index was. But what if we had one where you didn't have a numerator of 1? Okay, so what if we let, oh, sorry about that, bring that down. M and N represent integers. Okay, 0, positive and negative 1, positive and negative 2, etc., and so on. Okay. Uh-oh. Okay, so if we have, let's say, x to the power of m over n, remember, our denominator is always going to be your index. So that's going to equal the nth root of x to the power of m. Bless you. Or we can rewrite it as x to the power of m over n equals the nth root of x, and that entire thing to the power of m. They both mean the same thing. Okay. And same thing if you have a negative exponent. So let's say you have negative m over n. Then that's just going to equal 1 over x to the m over n, or x to the negative m over n in your denominator. Just like before, you just move it up to the numerator and make it positive. Okay, so let's say, for example, we want to simplify 32 to the 2/5 power. Okay, so 32 to the 2/5 power. Remember, your denominator is always your index. So that's going to equal the 5th root of 32. And you can raise that whole thing and square it. Okay. So now, if you look at it, we know that 2 times 2 times 2 times 2 times 2 is 32. So that means the 5th root of 32 is just equal to 2. So that 5th root of 32 in there, we can just turn that into 2 squared, which is equal to 4. Okay. Any questions on that one? Okay, so what if we had 81 to the 3/4 power? And sometimes you see the parentheses, sometimes you won't, so. Okay, so we know that for our 81 to the 3/4 power, our denominator is always our index. So we know it's going to be the 4th root of 81. And that becomes our exponent. So that's to the, our numerator gives us to the 3rd power. Okay, so we know that 3 times 3 times 3 times 3 is 81, since it's just 9 times 9. So we know the 4th root of 81 is just equal to 3. Okay, so this 4th root of 81 in here, we can just make that 3 raised to the 3rd power. Which 3 times 3 times 3 is just 27. Okay, so let's say for our next example, we wanted to simplify negative x to the 5th power times y to the 5th power and raise that to the 2/5 power. Change it up a little. Okay. Now, on this one, the negative is on the outside, so it's just like saying -1 times whatever your answer is. Okay, so you have negative x to the 5th, y to the 5th to the 2/5 power. Remember that becomes your root, or if you wanted to, you can distribute that first. Actually, it'll be a little easier to just distribute it. So if we make that to the 2/5 power, that just becomes negative x to the 5th to the 2/5 power times y to the 5th to the 2/5 power. Okay. And remember, that just comes from our exponent property. A times b to the n equals a to the n times b to the n. Okay, so now we have an exponent and another exponent, which comes from the property a times m to the nth power equals a to the m times n. Okay, so we just multiply our exponent. So you have x to the 5th times 2/5. Uh-oh, bring that down a little more. Times y to the 5th times 2/5. Okay, so we know that 5 times 2/5 is just like saying 5/1 times 2/5, where those two can cancel out. So you're left with just 2. So you have negative x squared y squared as your final answer, since those denominators cancel. Okay. So any questions on this one? Or any of those, rather?
Will the negative distribute to the y to the 5th? Or just the x?
Which negative? You mean the negative here?
Yeah. Or
Oh.
out front up there.
This one?
Yeah.
You could put it there, but for the most part, you just usually leave it right in the front.
Okay.
Like if you want to make it x squared times negative y to the 2nd power, you
Or would it
could.
be like negative x to the 5 and like negative y to the 5th? Or do you just have to distribute it to the first one?
It's not really distributed. It's kind of so it's kind of like if you have, let's say,
It's just out.
yep, negative 2x.
Okay.
So let's say 2x to the 5th power. If you have that, then you can make it 2 times negative x to the 5th if you wanted to, or you can make it whichever one. But it's just a negative. You have 3 negative numbers and 2 unknown variables just being multiplied.
Okay.
So you can kind of shift it wherever you want it.
Okay.
All right. Make sure draw a line through that so I won't think it's part of the actual problem. All right, any other questions? All right. One still right. Okay, so let's say if we have negative 16 to the negative power, well, the power of negative 5 over 4. Yep. Okay, so we know by looking at this one, you have a negative exponent. So you have x to the negative m over n. Oh, make that a little longer. It's just 1 over x to the m over n. Okay, so we're going to get our negative 16 to the negative 5 over 4. We're going to make that 1 over 16, or negative 16, to the 5 over 4 power. Okay, so all we did was get our exponent, make it positive by moving it to the denominator. Okay, now if we remember, that denominator is going to be our index. So we have the fourth root, 1 over the fourth root of negative 16, and that raised to the 5th power. Okay. The only problem with that is you can't find an even index with a negative radicand. So you can't find any four real numbers that, well, any real number that multiplies to itself 4 times to give you negative 16. Okay, so here's no real solution. Okay, because we know that the fourth root of negative 16 no real solution. So this would be your actual answer. Or in some cases, they would have you just have an empty solution set. Clean that up a little more. There we go. Okay. Any questions on that one? Okay. So what if we wanted to simplify 5 to the power of 2 over 7 times 5 to the power of 3 over 7? Okay, so with this one, we have a to the power of m times a to the power of n equals a to the m plus n. Okay, so that means we have 5 to the power of 2 over 7 times 5 to the power of 3 over 7. Here you have the same base, so you add the exponents. Here you have the same base, so you just add your exponents. 2 over 7 plus 3 over 7. I'll clean that 3 up a little bit better than that. There we go. Which gives you 5 to the power of 5 over 7. Which you don't really can't solve without a calculator, so we just leave it there. Okay. And one thing you want to remember, just a quick note, because I've seen this mistake over and over. Let's say if you have 5 to the, let's say, second power times 5 to the third power, that does not equal 25 to the fifth power. You don't add those together. So if your bases are the same, your simplification will still have the same base. So you don't want to multiply your bases.
And does that rule only apply for multiplying, for adding, or just random?
Well, with adding, you'll just get, like, if you have the same base and exponent, then you'll just multiply it by however many times you added it together. Okay. Any questions on that one? All right. Okay, so let's say if we have a to the 2/3 power times b to the 1/2 power, we raise that to the 6th power. Okay, here we have a product and we have a power rule here, so we have to use a times b to the nth power equals a to the n times b to the nth power. Okay, so we know that a to the 2/3 power times b to the 1/2 power, and that raised to the 6th power, we're just going to distribute that exponent. So you have a to the 2/3 power raised to the 6th power times b to the 1/2 power raised to the 6th power. Okay. Which neatly sets us up into our other exponent rule. Is a to the m power, and that raised to the nth power, it's just a to the m times n. Okay, so this becomes a to the 2/3 times 6 times b to the 1/2 times 6. Here we can see here that 2/3 times 6 is just 2/3 times 6/1, which is 12/3, which is 4. So you know this just becomes a to the 4th power. And we see here that 1/2 times 6 is just 1/2 times 6/1, which is 6/2, which is just 3. So that becomes b to the 3rd power. And that is your final simplified answer. All right. Any questions on that one?
You can just cancel, right? Instead of having to.
Oh yeah, if you want to cancel, you could.